Welcome our webinar today. Here is Milena Vilches from ESQ Statistics Division. And today we will talk about Agile Process Innovation, Agile Lean Six Sigma for results. Today we have a great presenter, Jay Arthur. So Jay, hello. Could you introduce yourself and start the webinar? Go ahead.
Sure. Make sure I can show my screen here. There it is. All right. See if everybody can see everything they're supposed to see. All right. Are you seeing my screen?
Yes.
Okay. So hi, I'm Jay Arthur, author of Lean Six Sigma Demystified, Lean Six Sigma for Hospitals, and Agile Process Innovation, which is a book I wrote before the pandemic started. I'll give you a link where you can download that later. And I got involved in quality improvement in 1989 and 90. And I learned from Florida Power and Light and been doing quality improvement and things ever since. We make the QI macro software. So I've worked with companies from manufacturing to healthcare to whatever. And I'm very interested in how do we apply Lean and Six Sigma to itself so we can start getting results in a more timely fashion and actually figure out who are the best people to continue on into more advanced training. So that's a little bit about me. Been at it 30 some odd years. I don't know. I've talked to people all over the place. I'll be exhibiting at ASQ, LSS in Phoenix, and then WCQI in Denver next year. So if anybody out there wants to come visit, feel free to stop by the booth. We'll be there. Do you want me to just get going? I'll take that as a yes. All right. So one of the things that bothered me is even with my training was like TQM week-long team member training and a week-long team leader training. And it just seemed like people weren't getting through. There was great training, but oh my gosh, we just did not seem to know how to get results. And then Lean and Six Sigma came along, and there was 2 and 4 week trainings. And I've gone to a lot of conferences, and I hear, trainers complain that they feel bad because that's what they call one and done. People do one project after their training, and then they're done. They don't do anything else, which I suspect is kind of a waste. All right, that's kind of a waste. So what I want to do is suggest to you some ways we might go about getting results really fast and use it as a stepstone to figure out who should continue on into more advanced training. So companies have been stumbling onto this approach, and so I saw several presentations before the pandemic, and this is the way I've been doing it for 2 decades. So this is the kind of thing that I think can really help get results in a timely fashion and accelerate the implementation of Lean and Six Sigma. It's also great for identifying the best candidates for green and black belt training. Most companies just go out and go, well, who wants to be a belt? And people raise their hands and they go off to training. And that's why we end up with one and dones. And what are the 7 key tools for Lean and Six Sigma success? And how can you teach Lean and Six Sigma in 1 day or less or more, 2 days sometimes, and get results? So that's my adventure for today. Back in 2017, there was an article in the Harvard Business Review, and this guy said, Six Sigma is too complex and time-consuming to fit in a regular work day. We need tools that don't require an entire organization to undergo weeks-long training programs. This is the Harvard Business Review, and this was some years ago, right? So I want you to get this idea that leadership is looking for results. They could care less about Six Sigma. They don't care what it gets them there, as long as it gets them there, okay? But I think that we as members of this community can help make that happen. Now, back in the last century, um, if you look at it, farm employment went way down, and then service and manufacturing increased pretty steadily. And then ASQ was formed in 1946. It was actually ASQC, for American Society for Quality Control. That's one of the things that I think Schuhart did us no favors by focusing on the word control, because Americans hate control. So what we want to do is see if we can come up with better language, which is why ASQ became ASQ instead of ASQC. So traditional training starts with a big binder, 2 to 4 weeks of training, and you end up with a green belt or a black belt. And then, according to most people, projects take anywhere from 4 months to 16 months. No, that's way too long. Okay, that's just way too long. Leadership will not put up with it in the 21st century. And I don't know if you can see behind me, but I have lots of big binders that I went through lots of days of training on. So this is, I think, the current model, and I think that model is obsolete. That's last century. So as I go to look at things, there's a lot of tools in Lean Six Sigma. There's a long tail of tools. And yes, if you go into more exotic things, you're going to need more exotic tools. There's more tools. But I found that about 4% of the tools will solve most of the problems that we face on a day-to-day basis in performance improvement across industries. Doesn't matter if it's healthcare or manufacturing or whatever it is, we don't need exotic tools to get stuff done. And then in about 1950, this huge division started. Manufacturing has been shrinking. It's actually down below 13% of employment now. And over 80% are for service industries. And ASQ has really been focused on manufacturing. And that's why its membership rates have gone down from about 120,000 when I started to now about 30,000. And so I think we continue to ignore what is the current way of going about things. So when I, I've been doing this a long time, and I talk to a lot of people, and yes, there are complicated problems for which you need full-blown DMAIC, design of experiments, and complexity, but in general, most of the problems are not complicated. There are very simple problems, and you can fix those with trial and error. And I've talked to people, and they call me up and go, well, Jay, we've got this thing, but we think we know what the answer is, but we want to apply Six Sigma to it to see if we get the same answer. And I say, no, just go fix it. Don't waste your time on that. That's just silly. But there are huge, probably 80, 90% of these things are uncomplicated problems. It needs data and 7 key tools I've found to solve most of them. And I was sort of in between TQM, PDCA, and DMAIC. And so I kind of had my own methodology, but it's really focus your improvement, improve, sustain, honor your progress, rinse and repeat. And this is a way we can start to get results in a more timely fashion. A guy named Scott Brinker wrote a book on hacking marketing. And he said the spearing of hacking can be adapted and applied to general business management, not just technical innovation. So we could hack Lean Six Sigma. And since I'm an old software guy, there's good hacking and bad hacking. So we want good hacking that gets what we want in a timely fashion. I don't know if any of you have ever read Tim Ferriss, but Tim Ferriss is all about finding the minimal amount of effort you can put in to get the outcome that you want. And so this is a different way of thinking about how we want to approach this. Now, what I found was that I went to a number of presentations in 2019, 18, 19, and people were presenting about how they'd rediscovered what I've been doing since about 2000. First was Christus Health. And Christus Health was, doing the typical green belt, black belt training, but they weren't getting results. And the leadership team came down and said, well, I want you to figure out how to train people in a day and start getting us some results. And as you can imagine, the trainers at Christus Health were freaking out. they said, okay, well, we'll try. But what they did was they came up with a different approach to doing this where they could train people in one day and get results. And then I saw Novartis do a similar presentation. They were taking 2 days, and they were able to collapse the cycle time to get drugs out, sample drugs out to doctors so that you could, get them into the public. And so they did that in 2 days. And then I saw another presentation by Crayola, and they also took their multi-week belt training and collapsed it down to 2 days. Same thing with Underwriter's laboratory. Now they have like 14,000 people spread all over the planet. And so what they did was they built an online training, and then they had another day where people would get together locally and work on a specific problem. And I've got a free yellow belt training online, which you can take. I have a free Agile Lean Six Sigma trainer training you can take online. So I built all of that, and you can reuse that if you would like, and I'll show you where you can find all of that. So what did they do differently? Well, first there was pre-work. Number one, they selected teams that have a real problem to solve and data about that problem. If you just wanted to go to training, no. If you didn't have a problem to solve, no. If you didn't have data about that problem, no. You could not go to this training. You had to have teams that have a real problem to solve and data about that problem. And they'd get maybe 3 or 4 or 5 teams together, maybe 4 or 5 people on a team, and they'd spend 1 day in training. And they'd train the teams in key improvement tools and apply that to their data and their problem. And then they would send them off to implement countermeasures and get results. Now, guess what? Oddly enough, these people started getting results almost immediately. 1 day of training, go implement the thing, and start getting results immediately. And there was one wonderful byproduct of this, which they discovered, which is in a group of maybe 20, 25 people, 2 or 3 people really showed an aptitude, a desire, a love, a passion for improvement work. Guess what? Those 3 people should go on to green belt or black belt training, right? We don't want to train everybody, because I'm telling you, most of the time you cannot tell in advance who's going to be good at this and who ain't. So what do we want to do? We want to get and find the right people. So this was very good as a way of screening the people who should go on to additional training. And those people ended up doing a lot more things. Now, I'm not saying that green belt and black belt training are bad. I know some green belts and black belts that are slaying dragons and saving millions, if not billions of dollars in their jobs. So I'm not saying that does not work. I'm just saying that what it doesn't do is pre-select the people who are best at it. The people I know who are good at this have just a passion about it, and they just happen to be in a class where they learned all about it, and off they went. So let's start to talk about how do we hack lean. How do we hack lean? Well, if you've seen all of the training we have, very often people are busy talking about tack time and changeover time. And it's all about what's going on in the arrows, right? It's about what's going on, not in the arrows, but in the activities. That's true in a manufacturing line where everything butts up against each other, right? Where the line is connected. But that's not how services work, right? In a service industry, it's all about the arrows, right? There's an arrow between all of these processes. And so where do we start? Well, you want to shrink the arrows. And how do you do that? With value stream mapping. And I've done this multiple times. This is a bunch of nurses laying out a value stream map of how things get done in a nursing unit. And the thing you discover is that in services, 90% of the time is spent in the arrows in between. The patient is waiting. If you go to anything like a Panera, your order, you take an order here and then you wait and you wait and you wait. And then eventually something comes out the other end like a sandwich. It is the delays in between, which is where all the opportunity is. And as you discover that maybe 3 minutes out of every hour are actually spent on the thing going through the process. But most of the other time, 57 minutes is for delay. And if you collapse that, you get significant boosts in productivity and profitability. There's a medical center up in Seattle, Virginia Mason, and they started reworking how everything worked in their hospital. Nurses used to spend just 30% of their time with patients. Now they spend 90%. Well, that translates to better outcomes for patients. It translates to better satisfaction by the nurses and by the patients and by the doctors, right? So this dramatic improvement can be done. Similarly, I found other things. I was working with a credit union, and they had long lines on a Friday, and that's because they required anybody wanted to take out more than $200 had to get an approval by the manager. Well, the manager was running all over, trying to approve things. And I said, well, why don't you bump that to $500 or $800? It was like, oh my God, that's heresy. And I said, well, you don't want to have to wait on somebody to come approve it, because they approved. How many did they approve? All of them. Okay, well, just move on. And so they changed the amount of dollars that you could hand out. And guess what? The line shrank. So you didn't have to wait as long on a Friday afternoon after you got paid. This is the sort of thing that's very powerful. And again, you can do this using these things. All right? Not hard work, not hard to do at all. And here's a spaghetti diagram. So what we did with some other folks was say, where is all the stuff and how do nurses move around in a nursing unit? And very often nurses can lay this out in an hour, redesign it in an hour, and then I send them back to reorganize everything, and they start saving 50% of their commute time wandering around in a nursing unit. These are the kinds of things that are very easy to do, and you don't have to worry about tack time, right? You don't have to do anything else, right? So this, you don't have to worry about changeover time. So I want you to get this idea that this is very useful. I think somebody may have just put in a chat. I apologize if I didn't hear it. Let me see if I can find my chats in here. Nope, guess not. Okay. So as we go along, feel free to chime in. These are the things that I think are important. Let's talk about them. Dale says very few people in a nursing unit want to do more. That's right. They don't want to do more. They want to do less, right? But the secret sauce to that is getting rid of all the delays. If all you're doing is commuting, you spend less time with patients. These people want to spend more time with patients, helping them get the outcomes that they want. They love that. They don't want to do stupid stuff, right? So I think if you go into a healthcare setting, these people are being delayed unnecessarily. And so I think the secret sauce here is to collapse that time that they spend commuting. And there's a lot of commute time. So that's a little bit about lean. And I have found that to be incredibly powerful. We can get people together for an hour, maybe two, lay out the old stuff, come up with a design for new stuff, and spontaneously you save a bunch of time. I worked with E470 here in Denver, and they were having, it's a big toll road around the town, and they had certain areas which were prone to accidents, but they were also trying to figure out how to get help to people if their car broke down or whatever. And so we designed where everything was, and they went through this process, and they said, well, maybe we should move these things over here and that thing over there, and we should station people, every so many stops, and so that we have somebody who can get there in a timely fashion. And they implemented that. They also were able to save $2 point something million the first year from Six Sigma enhancements that they did. These are the kinds of things I love to do, and I think they're fun. All right, so let's talk about how do we hack Six Sigma. So one of the tools that most people don't teach in Six Sigma training are pivot tables. And pivot tables are very powerful at summarizing lots of information. And I have found that the invisible low-hanging fruit often lives in these files and these systems, like how much scrap did we have by production, by machine, by whatever, or how many patient falls did we have and where did it occur, and things of this nature. So there's all this raw data out there, and I love raw data, and we'll talk about why. But you can summarize that with pivot tables, and a lot of people don't know how. And then there's control charts. And I believe that if you really want to get good at improvement and to sustain it, I talk to far too many people who say, "Oh, Jay, we made this great improvement," and they say, "Well, but 6 months later it was gone. We made this great improvement. 6 months later it was gone." And I would say, "Well, did you implement a control system with control charts and corrective actions? Did you do the C in DMAIC?" And they'd say, "Well, no." And I'd say, "Well, that's why your thing went away, right? That's how it happens." So control charts are essential, and Pareto charts or histograms. And we want to do some cause and effect diagramming, some countermeasures. We want to be able to show the before and the after. And this is very important to prove that you've actually done something. So we can do that with control charts. We can do that with Pareto charts over here on the right, or with histograms to just show the before and the after. Now this, I would love to see more of this, but I've been to ASQ and Magnet Nursing Conferences and Institute for Healthcare Improvement. I see so little good improvement projects and stories. It's very disappointing. So at the Magnet Conference, this is a bunch of nurses. In 2023, bar and line and pie charts were 87% of the total charts used. 87%. I consider these the three stooges of charts. Line and bar charts are the dumb and dumber of charts, right? So, and especially, I don't know why they have so many bar charts, but what we're trying to do is improve healthcare quality. Now, according to the IHI, the Institute for Healthcare Improvement, we spend $3 trillion a year on healthcare. Manufacturing is only $2 trillion in total, but healthcare is $3 trillion. Of that $3 trillion, $1 trillion is for waste and rework. And that's just on the healthcare side, not including the patient side. So some of you probably had unpleasant experiences with healthcare. But that's this huge opportunity that exists. And they're trying to do better, but frankly, they're just not, they don't have the pedal to the metal. The IHI has been around for 40 years, and still, I say they're admiring the problem very often. This is the Institute for Healthcare Improvement. They had bar and line charts. That was 53%. And I've been tracking this for about 8 years now, and it hasn't really improved dramatically. It's still staying where it's always been. Yes, it's easier to draw a line in a bar chart in Excel, but that's not going to get you where you want to go. So I want to talk just for a second about what's wrong with line charts. So this is a type of infection rate, a urinary tract infection. You can see here the goodness of fit metric is only 30%. Most line charts with trend lines on them have no goodness of fit metric. So you don't know if it's any good or not. And I often say that trend lines are fake news. They might look like something, but they're not. So I went ahead and took that data and drew it as a control chart. And it's had a C chart with one out of control point, but there's really no process improvement here. And I go to these conferences and I see people standing in front of these posters and they're taking pictures of their cell phone like it's gospel. They're going to go back and waste all their time fixing it or implementing it, all right? This is not a good choice. So nice stable process afterwards. Here's another type of hospital-acquired infection. And in this case, our R squared is 53%. Well, that's a little better, right? But again, most of these had no goodness of fit metric on them. If you draw that as a control chart, you see that there was a before and then there was a process improvement. We went from 9 a month down to 5 a month. That's pretty good. And so these are the things we can do with a control chart that we can't do with a line or a bar chart. So I think that line, bar, and pie charts are the three stooges of charts, the dumb and dumbers of charts. And we need control charts, Pareto's, and histograms. These went to college, took statistics so that you don't have to. Now, this is the statistics division, and you guys are more skilled at this than the average Joe or Susie. But how do we put these tools in the hands of the average user so we can start making real progress? So one of the things that I like to do is stick figures. But anyway, is the line chart. Is that good or bad? I don't know. Is bar chart. Is that good or not bad? I don't know. And this woman goes off and draws a control chart and a histogram and says, oh, yes, it's stable and capable, right? These things can tell us how we're doing and can we rely on it to be production, really support what we're doing. So I want you to get this idea that most of the data in the world is overcooked. And what do I mean by that? It's been over-summarized. Now, I don't care if it's scrap or in this case, it's deaths over bypass graft surgeries. Summarized data has very little nutritional value. It's very hard to solve problems with that. You can make a nice control chart with it, but it's not going to assist you in really drilling down into the data. So I'd like to invite all of you to go on a raw data diet. And where do we find that? Well, you can find that in all kinds of places. Ordering systems, purchasing, procurement, orders, invoicing, sales, medical record systems. There's a lot of systems that every company has. And there are people out there that have spreadsheets that are filled with line by line, row by row detail about everything that's gone wrong. Guess what? We can use that data and turn it into a real improvement story. And at the minimum, we need to know when did it happen, where did it happen, and what happened? What was the problem? And if you have a how much, who, and why, that's fine. That's also useful. So if you have data like this is hospitals denied insurance claims. We know the where and the when and the what and the how much happened. And so denied charges, you don't get paid, right? I mean, how many of you would go to work if you didn't get paid? But that was worth $5 million a year. If you have data that looks like this, here we have what machine did it happen on, what type of scrap code, and how much weight and pounds. Look at this. Scrap weight, 3,800 pounds. If you have something like that, that was worth $1 million a year. So I want you to get this idea that this kind of raw data is where the invisible low-hanging fruit lives, right? Everybody talks about low-hanging fruit, but most people can't find it. This is where the big money lives, is in this kind of file. So what do we want to do? We want to be able to take that raw data, pivot it, categorize it, and turn it into some sort of insights for action. Pareto charts, control charts, and so on. So let me tell you the improvement, the denied insurance claims story, so you get an idea how this works. So I always start with a control chart, defects, mistakes, errors, costs, whatever. We could have done that with something around measurements or leading to a histogram, but this one was counting defects, mistakes, and errors. And in manufacturing, most production lines are pretty good, or you wouldn't be in business. But the backroom functions, all those service functions that feed that, are where there can be sluggish, error-prone issues, billing errors. I mean, just all kinds of crazy stuff. And so what you want to do is come back and look at what's going wrong upstream, right? Not just when you produce it, but then you could have shipping errors, or we order the wrong thing and we ship the wrong thing. Well, that's not a problem with the production line. Production line's fine, right? It's just we made the wrong stuff. So what we want to do is go backwards and look at these things. So here you have things like charges coded as denials. And for this group, it was over $1 million a month. It denied insurance claims. Now, I'll tell you, in a hospital, you can do a lot of things with $1 million a month. You could hire another transporter. You could do a lot of things to make patient flow better. And then we want to go deeper. We want to apply what I call the 450 rule. Now, all of you are familiar with, Pareto's rule. 20% of what you do produces 80% of the mistakes, errors, waste, rework, lost profit, patient harm, whatever it is. But within that 20%, Pareto's law still applies. So as little as 4% of what you're doing is producing over half of the waste, rework, lost profit. And so what you want to do is use data to narrow us down to that 4% so that we can actually start to move the needle. Now, what does this mean? This means you don't have to fix everything. Too many people think you have to fix everything. I had a friend, she worked as a tech writer for one of the aerospace companies, and they had everyone be trained in Lean and Six Sigma, and then you had to do 2 Six Sigma projects a year. She was a tech writer. Come on. That's not where the pain and suffering is, I'll tell you what, unless for some reason you put the wrong thing into the tech document. But the idea here is you don't have to fix everything. As little as 4% will solve over half of your problems. So 4%, that's 4 steps out of 100. That's 1 step out of a 25. Creates half the waste, rework, and lost profit. I call that the $1 million misstep. So we wanted to use data to find that thing and fix it. So for the healthcare company, what did we do? Well, we had the big issue at the higher level, at the 80-20 level, was we had timely filing. That was 61% of the total, almost $8 million a year. Well, all these others are fine, but that's the big dog. And when we drill down into this thing, guess what? They discovered that one insurance company was 64% of the total, right? One thing was causing most of their pain and suffering. And so that made it super simple. And you'll laugh, but when I went in to work with these people, they've been trying to fix this for a year, right? And when I walked in to work with these folks, they said, well, are you a doctor or a nurse? And I'd say no, and that's good for you because I don't buy into all of your limiting beliefs about how this works, all right? I can look at the data mindlessly and help narrow it down to what we can fix. And so it took me about 3 days of analysis to figure out where we should go. Then we took about 2 hours in root cause analysis on a Friday afternoon. And guess what? They figured out what the countermeasures were and came up with ways to work long-term with the insurance company and fix their own process to contribute to reduce denials. And they figured it out on a Friday. They implemented the process change on Monday and started saving almost $400,000 a month, or about $5 million a year. They also found a way to save like $24 million in rejected claims and shorten their cycle time for appealed claims from 300 days down to 45 days. That means you get your money much sooner, which means you can do a lot more with it. So that's the pattern I've seen that's very powerful in terms of getting results in a very timely fashion. And if we have that data, it's pretty simple. So that's what a world-class improvement looks like to me. Control charts, Pareto charts, cause and effect diagrams, right? Comparing control charts, comparing Pareto charts. Now let me show you how that could work. Now, the QI macros, we have a whole bunch of sample data in here. And here's our improvement project wizard data. But here's some examples like by date, by line type of defect. Could be lost time analysis, by date, lost time, and cause. It could be time to thrombolytics, nursing unit defects, the denied insurance claim, ICU medications, patient falls, all kinds of stuff. But here's an example where we have by date, by line type of defects on a production, on a packaging line. Now, I'd done this manually for a long time, so it took me hours and sometimes days to do it. But I created in 2016 and 17 an improvement project wizard. So you just select two headings, and guess what? It'll go crunch through, do pivot tables. If it can find a control chart, it'll build a control chart. It'll look for high level 80-20 level Paretos, lower level 450 level Paretos, and then it'll keep drilling down and create a fishbone diagram. And it'll actually build entire improvement projects just this fast. And if you can see here, what it's done is created me a summary. So we got a control chart and two different projects. And the high level Pareto, 80-20, lower level Pareto, the 450, and a fishbone diagram and our problem statement. So here's our control chart. So we have a certain level of packaging defects by day. And if you see here, line 3 has over half of our total defects. So I'm going to focus there maybe. And within that, folded flaps is 40% of their total defects. And from that, we can create a fishbone diagram. During 2020, folded flaps accounted for 40% of line 3 defects. But it doesn't stop there, it keeps looking. And so it went by type of defect. Folded flaps, bent and damaged carton will not open are 2/3 of the total. If we fixed all three of those, guess what? We could collapse the defects in that packaging line by over 50%. And then we could drill down, and here you can see that line 3 had 79% of folded flap defects. And now we have a nice fishbone problem statement. Line 3 accounted for 79% of folded flaps, which cause waste and rework. Now, one of the ideas I'd like you to get here is that in my training, a lot of the trainings I've seen, people say, well, just get people together and brainstorm a problem to work on and then go figure out where to get, start collecting some measurements. No, let's start with measurements. Let's let the data lead us down to something that's fixable. And then once we have that, who should be on my team? People in line 3 that know something about folded flap defects. That's it. I don't need people from line 1 and line 2. I don't need a bunch of other people, right? I don't need people that know something about ink smears. I don't need to know that, right? I need the right people. So this takes us to a point where we can actually get people focused on the problem and get it going. And that, I believe, is one of the ways we can hack Lean and Six Sigma in a big hurry. So control charts, Paretos, high level, low level, fishbones, comparing. We can do that with histograms as well. Now, another thing we could do about Six Sigma is hacking Lean and Six Sigma training, right? So here's all the formulas for probably a P chart. And that's kind of a waste of time. If you have software like QI Macros or Minitab or whatever the heck you have, don't care. We all use the same formulas. You're going to get the same answer. But trying to teach people how to calculate these things by hand, that's just a waste of time. The average Joe or Susie wants to get a result. They do not want to know how to do this. So you don't need to learn the formulas. We all use the same formulas. And back in 2006, I said, I don't think you need to learn decision trees. I found trying to teach people decision trees is very confusing to the average Joe or Susie. So back in 2006, if you've seen these decision trees to pick a control chart, is it attribute or discrete or variable, right? And then how many subgroups do you have? Like, and I'll tell you what, I was on a webinar. IHI had one back during COVID, and they were talking about statistical process control and how to use the right chart. And as soon as they started talking about this, the chat line lit up. Well, this is where I get lost. This is what I find so confusing, blah, blah, blah. All right, so this is very confusing to the average person. And what we want to do is get more people engaged in quality improvement. That's all I want to do. More people everywhere doing this. And so one of the strange things about how I built QI macros was I started with the way Excel did stuff, and I developed the initial version on a Macintosh. So Macs are pretty easy to use. Excel was built on a Mac, and so I followed their strategy. Select some data, click a button, get a chart. And what I discovered was once you select the data, I can help you pick the right chart. Now, everybody else, every other software out there asks you to navigate this decision tree before you choose your data. I ask you to select the data first, so once you select the data, I just built that into our control chart wizard. So here's how that works. If you have data that looks like this, if I select that data with my mouse, I can click on our control chart wizard. If I know what I'm doing, sure, I could go by and do an X bar R, but I could actually do a control chart wizard. And it's going to do a number of things. So it's going to look, it's decimal. That means it has to be variable. And there's multiple subgroups, which means I'm probably going to need an X bar R chart. Excel is starting to love to show this error sometimes. Sorry. So here's our control chart. So we have a nice stable control chart. So it looked at that data and said, oh, that must be an X bar R chart. And it also took that and strung them all together so that you can see them side by side. Some people want to see things side by side. We have fill in the blank templates, so you just drop your data in and your chart grows. So I could take this and then on an ongoing basis continue to keep more data points adding to my chart. And that's my original capability suite. So what does this do? This speeds up the learning process for the average person. So select data, click a button, get a chart. They don't need to know all those decision trees. And we have chart wizards that'll do the same thing, stat wizards that have the whole decision tree for statistics built in there to do things like ANOVA and Levine's test and F-test and T-test, equivalence tests, and so on and so forth. So these things help train people early on. So for example, if I have statistical data here, so if I have something like this, yes, I could come over here and do descriptive statistics and F-test and T-test and whatever. Or the stat wizard will look at that and go, what can I do with that data? And it'll crunch through there and do F-tests and T-tests and equivalence tests, crunch through all of that, put all the data together, and tell you that the variances are not different, but the means are equivalent. So it's going to read p-values and things and take a look at that. Now, I know we don't love p-values in statistics, but that's what a lot of people look at. So here's our F-test and a T-test, and then did an equivalence test. And you can see here that our two sets of means are equivalent. The great thing about these wizards is it's automating how people do this work. Now, what do I think is important? I think people need to understand the patterns. What do we want to do Six Sigma 101, we want to reduce variation. Duh, right? And the other thing is move the center line up or down. We want to reduce defects, mistakes, and errors. We want to increase customer satisfaction and profits. The funny thing I've learned is when you tell people what the outcome is they're trying to achieve, they get pretty good at figuring out how to move the needle. And so this is a very powerful insight. And back when I took my week-long control chart training, we spent hours using a manual calculator to calculate all the formulas for all the charts. And we spent about 1 hour talking about what the charts tell you. I think you need to know more about what the chart tells you than how to calculate it. A lot of people disagree with me on that, but that software automates it, and I don't think learning the formulas does you any good. Similarly, with reducing deviation, we want to move things on target so we can get this thing to move to the center. And then I tell people if you have too much variation, we want to reduce the spread. And once you show people what they want to achieve, they seem to be pretty good at doing that. So just a few thoughts there. Same thing with cycle time deviation. We want to collapse it and get it as short as possible. And when you get all these silly arrows out of the process, you can go a long way. All right, so we've been pounding right on through. Why do we need to pivot now? Why do we need to change Six Sigma? To avoid extinction. You may not notice it, but I do. Right? Six Sigma, ever since Jack Welch retired from GE, it's been sliding. Statistical process control, even Google search for all these terms has been sliding. And so it's going away or going down to trivial things. So what I'd like you to consider is that traditional stuff is about big implementations. I'm about small agile teams. People work on the 4% that really needs to be fixed. We have a lot of rigid processes. No, we need to be more agile. We want to maintain the status quo. Well, this is how we did it last century. No, come on. Let's speed up and accelerate speed and adaptability. Big projects. No, laser-driven, data-focused projects. If your project's taking a year, you've taken too long. And maybe there's silos. Sorry. And I'd really get people engaged. This is about the traditional is about complexity and all the possible ways we can solve problems with no, 7 tools. Let's use some simplicity. So a lot of people started with gut feel, common sense, and trial and error. And a lot of managers got promoted because they were good at that. And then we started collecting data, analyzing data, improving, and building that problem-solving capability. We can get to where we have people that are called money belts. People can actually use the tools qualities to save money. Where I said I've seen a lot of people with a lot of belts who haven't figured out how to save money. I know a lot of belts who saved a lot of money, but I also know a lot haven't. So how do we get to hassle-free? A hassle-free planet, a hassle-free America, hassle-free in terms of delivering the quality of service people expect. Now, I want you to get this idea that you can train people in a day. You can identify the best candidates for training. This is how companies are using Agile to succeed where traditional implementations have failed. And there's a few key tools you can use repeatedly that'll solve most problems. And as I mentioned before, if you go out to our website, qimacros.com, you'll find that we have QI Macros training, but we also have Agile Lean Six Sigma training. So this will teach you how I do this, how I train people in as little as a day and get results using QI Macros. And we also have a yellow belt training. And, oh, come on. But this is a free training, about 8 hours long. People can go out here and learn online. And then if you want, take our test and get certified, you can do that for $97. If you have U.S. military of any shape, color, size, or form, they can get this certification for free. Active, veterans, retired, any U.S. military. So we provide that as, I want all of our people using that, because I think, military is another great place to save money. I saw one write-up where there's some base out in New Jersey where they rehab things like Humvees and all these things, but they were able to use Six Sigma to save $1 billion a year. $1 billion, 1 billion with a B, in terms of rehabbing all these vehicles that are coming back from Iraq and Afghanistan and so on. So this is a tremendous tool for everyone. So that's our free training. White belt, yellow belt, you name it. Now, if you come over to our Agile free training here and scroll down a little ways, you'll find here's my Agile Process Innovation ebook, an action plan, and our prescription. Now, right here, you can see this is my book. So this is the Agile Process Innovation book. And it was pretty funny. It was 2023. I was at the conference, and there was a guy from Norway there. And I was talking about, how you could use Agile, Lean and Six Sigma, and I was giving out free copies of my books. So if you come by the booth, I'll have a book. But he was all, kind of brow furrowed and everything else. But he took the book and he read it on the plane going back to Norway. The next year, he comes back to the Lean Six Sigma conference, and he walks up to me and he said, when you told me about this Agile Lean Six Sigma stuff, I scoffed. And then he smiled and he said, but it works. So that's my anecdotal evidence. This is how I've been training everybody over the years. Now, we also have an Agile Lean Six Sigma $1 Million Money Belt action plan. And this is the little workbook that I use to train people. It's 16 pages, not a big binder, all right? And I have found that this is a super easy way to get people to learn the patterns of improvement and build good projects. And let's see if it'll let me. I've got to make this a little smaller, don't I? And here's my Agile Lean Six Sigma prescription. This is a 1-page about how do we hack Lean and Six Sigma to get results, and our 4-minute Six Sigma hack, which is the improvement project wizard. What are we looking to try and build? And one of the things I've found is as you make things simpler and simpler, and streamline, simplify, optimize, at some point you get some sort of an insight about how to innovate, how to redesign an entire process. Now, you have to understand, I lived back in the 1980s when re-engineering was a big thing. And I watched my phone company try and do this multiple times and fail. I think 3/4 of all re-engineering efforts failed. Michael Hammer said, well, I don't understand. Well, guess what? It doesn't always work the way you think it will. Companies are not machines. They're people, machine, hybrid things. They don't always work the way you think they will. So this is one of the ways I've found that you get to innovation, but you do it by simplifying and streamlining and optimizing. So that's a lot of high-speed talk about all kinds of things here. And again, you can go to our free webinar. And if you have questions, you can email me. I'm jay@qimacros.com. You can download my free book out here at the website or take my free yellow belt training. So That's what we've done. This is what I've been doing for the last 20-something years. And I hope this gives you some ideas about how we can hack Lean and Six Sigma and start getting results and start moving the needle in ways that we haven't done it before. Questions?
Okay, could you see the questions? Okay,
Oh, they're there.
and the chat.
Q&A? I see a Q&A. I don't see any questions yet.
Were nurses happy when they were spending 90% of their time with patients versus 30% before the process changed? Could you see this question?
No, I don't see questions.
Oh, I read it. Okay.
Okay.
Okay. Were nurses happy when they were spending 90% of their time with patients versus 30% before the process changes?
Yeah, so nurses like being with patients. They don't like being somewhere filling out forms or running around looking for supplies. They like being with patients. That's why they got the gig, right? So these people really like being with patients. They also makes it easier for them to be in a position where they can detect changes that might be causing problems. So yes, it's totally they love that stuff.
Thank you. And another comment is very few people in hospital sitting want to do more. This is another situation. Okay.
I think I answered that one.
Okay. Are there any challenges to consider, Jay?
Challenges?
Mm-hmm.
Well, yeah, number one, the thing I'm suggesting is heresy in the Lean and Six Sigma camp. But you have to understand that this is and once I explain to people, it's a type of screening process to get us to the people who are naturally inclined to this kind of data-driven improvement process. People seem to really go, oh, yeah, we could do, it's like their brain didn't know why you would want to do that. Most of the Lean Six Sigma training companies, they make money by billing weeks at a time, right? So they want longer days. Doing a one-day training is exhausting, all right? But for me, that was the way to get people to an outcome that I wanted. What am I trying to do? I was trying to get people through that frustration barrier. I don't know if any of you remember, but you were, I don't know if you remember that, it was when you first did this, it wasn't totally natural and you just didn't slide into it like it was easy, right? So there's a frustration barrier. But if I can get people through that frustration barrier in a short time, I always laugh because when I would go do these trainings, I was doing a training for a company that makes chemicals down in Texas. And I had a guy in the room, and he was wearing his tractor hat and chewing a wad of chewing tobacco, and he had his computer, his laptop in front of him, and so I started to show him how to do some of these charts and everything, and then I go around and have him do stuff, and I walk around, and this guy's pulled data down out of the server, and he started to crunch all the data in his about, I don't know, some sort of flow in the thing, and I thought, that's fantastic. You don't expect, the guy with the tractor hat chewing a plug of tobacco to be your number one student, but he was just racing forward with that stuff, right? And I find people that don't know and a lot of people are afraid of math and statistics, and they think this is going to be too hard, it's going to take too long, and oh my gosh, they come up with 1,000 reasons not to do it. And so that's another thing that gets in your way. But if you can get them through that frustration barrier very quickly, guess what? They quickly get on board, and you can do a lot of good in a very short period of time. So, I just say this is how I go about it. Let me help you or not. Let's see. Somebody asked if I've used hacking Lean Six Sigma in banking industry that's highly regulated. The thing about it in highly regulated things, you still have processes, right? And so you can actually sit down and crunch through the processes. I was talking to one guy, and he was working on reducing fraud. And so, we spent a little time talking about stuff, and he found ways to narrow the gap on fraud in a more timely fashion. So, nowadays, if somebody tries to buy something with your credit card and they're not where you are, I get a message from my card company that says, "Did you buy this?" No, right? There are ways to accelerate and automate all of these things, which I think are very powerful. Somebody asked if I would recommend opening a Lean Six Sigma consultancy in Brazil. And I will tell you, the IHI is training improvement advisors down in Brazil and all the in some of the hospitals and things. So I believe that yes, anywhere on the planet that we make stuff, people need help. Now, will I tell you that I make a ton of money as a consultant? No, not anymore. So I'm not the world's expert on consultancies. But if you can help people start solving problems, they'll notice. I think you can also help government, because government, oh my gosh, they need a lot of love. What other questions can I answer?
Okay, and then that's all. Thank you, Jay. Great presentation. And thank you, everybody, for participate today. This presentation and the RU will send by email. Okay, that's all. This is the end of our webinar. Thank you.
Thank you. Bye-bye.
Bye-bye. Bye-bye.